welcome back. In the first video of creating our Guess the Number minigame, we set up the UI. We learned how to use line edit, labels, and buttons to structure the game's visuals. We also explored how to style them and make everything look shiny and polished. In this video, we're going to add logic to our game, so let's get started. We start our journey by adding a new script to our main node. Save it inside the scripts folder and hit the Create button. Here, the first thing we're going to add are some constant variables to hold our color values. Constants are special variables that hold a value and keep it unchanged during coding and runtime. As the name suggests, they're not meant to change. Here, I've also defined the variable type statically, which in this case is color. In Godot, we can define what type a variable holds by using a colon followed by the type name. To define a color, we can use hex codes written as strings, or use RGB values. A string is simply a sequence of characters enclosed in quotation marks. For example, 00CED1 is a string that represents a color in hexadecimal format. In this case, I'm using hex codes to define my colors. By the way, if you're serious about building games with Godot 4 and want to master GDScript from the ground up, I've created a full course that walks you through everything, step by step. Whether you're brand new to programming or you've dabbled before, this course is built to make game development fun, practical, and achievable. Hey there, I'm Okapi, your instructor and creative partner throughout this journey. You'll build a set of cool games, each designed to teach you core programming concepts while sparking your creativity. From puzzle logic to animations, object-oriented design to UI building, you'll gain skills that open the door to building your own game ideas. Let me show you a quick preview of what's inside. We start by introducing you to Godot and its native scripting language, GDScript. You'll set up your first project, explore the editor, and write your very first game logic. Next, we dive into syntax. You'll master printing values, fixing common errors, formatting clean code, and using essential lifecycle methods like ready and process. Now we tackle variables and data types. Learn how to store game data with arrays, dictionaries, enums, and even 2D and 3D vectors, all essential tools for real gameplay. Control your game's logic with conditionals like if else and match. These tools help your game react and make decisions, from menu selections to enemy behavior. With loops, you'll automate tasks and build smart systems, whether it's traversing lists or updating gameplay in real time. Functions help organize your code. You'll see them in action through your first full project, Pixie Realms, a simple platformer with animation, input handling, and goals. Godot's signal system creates dynamic interaction. You'll build a demo game menu and HUD, connect UI elements to code, and trigger win conditions with custom signals. Singletons, also known as autoload scripts, help manage global data and simplify scene transitions. You'll create reusable managers for scoring, scene control, and UI. You'll recap core concepts by building two minigames, Spectrum Catch and Rock Paper Scissors, reinforcing signals, UI styling, animations, and scene logic. Time to level up with object-oriented programming. You'll create custom classes, use constructors, inheritance, and organize nested logic for scalable code. Your final challenge is a full puzzle game, Minds Detective. Build a grid-based logic game with custom visuals, input handling, and win-loss tracking. This ties it all together. So, if you're ready to turn your creativity into something interactive, whether it's your first game or your 10th, this course is your launchpad. Jump into GDScript from scratch and start building. You can find the link to the course in the description below. Now, let's get back to today's topic and put some of those ideas into action. Now that we have our colors, let's bring back the ready function. The ready function runs automatically when the scene is loaded. It's a great place to initialize variables, set up UI elements, or prepare anything that needs to be ready before the player interacts with the game. Let me quickly explain how the Guess the Number game works. The player has to guess a number between 0 and 100. Each time they enter a guess, the game checks if it's correct, too high or too low, and gives feedback accordingly. The player has a limited number of attempts to find the correct number. Now, let's define some variables for our game logic. First, we need an integer variable to hold the random number. I'll set its initial value to 0, because we'll generate the number later. Next, we need to track how many guesses the player makes, so I'll define another integer variable called countGuesses. To make the game a bit more challenging, I'll also define a max guesses variable and set it to 0 for now. Next, let's rename the lineEdit node to InputBox. Now we need some references to our nodes. To do that, I hold the Control key and drag the following nodes into the script, one by one: tries, feedback, input box, submit button, and play again button. This creates direct references to each node, making it easier to access and update them in our game logic. Let's talk about what a function is. A function is a reusable block of code that performs a specific task. It helps organize your logic, avoid repetition, and make your code easier to read and maintain. For our first bit of logic, I need a function to update the feedback label, so let's create it. I'll name it showFeedback, and it takes 2 arguments. The first argument is MSG, which is a string. This is the text that will be shown by the feedback label. The second argument is color, which is optional, and its type is color. To define an optional argument in GDScript, you simply assign it a default value when declaring the function. So before we write the function, let's create another constant called textColor and set it to the hex code C0, C0, C0. I'll pass this constant as the default value for the color argument in the showFeedback function. Let's talk about the function return type. In GDScript, the return type tells us what kind of value the function gives back when it finishes running. Since this function doesn't return anything, we can set its return type to void, which simply means nothing. To update the feedback label's text, we can access its text property and set it to the MSG we receive from the function arguments. To change its font color, we use the add theme color override method of the node. This method takes 2 parameters. The first is the property we want to override, in this case, font color. The second is the value we want to assign, which is the color we get from the function arguments or the default value we specified earlier. Let's test its functionality. Inside the ready function, call the showFeedback function. Pass a test message like testFeedbackMessage as the first parameter and the blue color constant as the second. Save and run the game. As you can see, the feedback label's text has changed, and its color is now blue. That's great. Let me add some extra space at the bottom of our script so we can see everything clearly. Okay, the next function I've planned is called startGame. I'll use it as the game initializer for each round. Inside its body, first I access the play again button variable and call its hide method. I do the same for the submit button, but instead of hiding it, I call show. If you're wondering why, it's because if the player loses, the submit button must hide to prevent further guess submissions. So whenever the game starts or restarts, we make sure the submit button is visible. Next, we reset count guesses to 0. Then we need to generate a new random integer for each game round. To do this, I use the randirange method to get a number between 0 and 100. To test the randomness, I call showFeedback and pass the num variable converted to a string, and that's exactly what the str method does. Let's save and run the game. Oh, we didn't call startGame yet, so let's fix that. In the ready function, instead of calling show feedback, I'll call start game. Save and run the game again. Okay, as you can see, every time I run the game, a random number is generated and displayed in the feedback label, and the Play Again button is not showing as we desired. Next, let's handle the input box submission. We'll create a function named input-box-submitted. This function's return type is also void. Inside it, the first thing we do is increase count guesses by 1 each time the player submits a guess. Next, we'll need to update our tries label text, but for now, I'll add a comment here to remind myself to complete that part later. After that, we need to validate the text input value to make sure it's a proper guess before we process it. First, I check if the input box text is empty. If it is, I show feedback to the player in red and then write a simple return statement, which means end the function here and skip the rest of the code. Let's save and run the game to test it. Okay, I forgot to actually run the function. So when can we call this function? That's where signals come into play. Select the Submit button node. Next to the Inspector panel, open the Node panel. You'll see a pressed signal, select it, and at the bottom of the panel click Connect. By doing this, a new function is added to your script that runs automatically when the player clicks the Submit button. In this new function, we can call our input box pressed function. We can also add another signal for when the player presses Enter in the input box. Select the input box node and connect its text submitted signal to the script. Here, call input box pressed again. Save and run the game. As you can see, if I enter nothing in the input box and press Enter, the feedback shows in red, exactly as expected. Testing it with the button press signal gives the same result. A brilliant enhancement we can add to the game is auto-focusing on the input box. This means that whenever the player enters a value, the box is automatically selected again. Or when we start the game, the input box is ready to take input without the player having to click on it. Let's create a new function with a void return type named Focus on Input Box. Inside this function, first we clear the box by calling the clear method on the input box reference variable. Next, we call the edit method on it to give it focus automatically. Finally, we'll call this function inside input box submitted. Save and run the game, but as you can see, it's not behaving as expected. Here's a simple trick. Before calling edit, we need to wait for the clear method to finish. We can do this by using the await keyword and adding a tiny delay. Use getTree.createTimer with 0.01 parameter and wait for its timeout signal. This simulates a short pause before focusing, ensuring the input box is ready. Also, call focus on input box inside start game so it's ready from the very beginning. Save and run the game again. Now, when the game starts, the input box is selected automatically. And when I press Enter or click the Submit button with empty text, the autofocus works perfectly again. That input box caret is still and not blinking. Let's fix that. Select the input box node, and in the inspector panel, expand the caret options. Check the blink option. Save and run the game. Nice effect, don't you agree? Now, let's get back to the input box submitted function and expand our validation logic. The next validation we can add is to check if the inserted text is numeric. I'll loop through all characters in the entered text and check if any character is not one of the numeric characters. If it's not numeric, we show the feedback in red, call our focus function to select the box again, and then terminate the function with a simple return statement. Save and run the game. As you can see, this validation works too. But what happens if the player enters a valid number? First, let's create a temporary variable named guess and convert what the player inserted into the input box into an integer. Now, we can check against our boundaries. If the number entered is less than 0 or greater than 100, we'll show feedback to the player saying they must enter a number between 0 and 100. We'll also call our focus on input box function to reselect the box, and then use a simple return statement to terminate the rest of the function. Before running the game, let me specify a color for this feedback. Red should work well. Save and run the game. As you can see, the boundary check is working perfectly. Now it's time to compare the player's guess against the generated random number. I want to write the comparison logic in a separate function named compareGuess and pass the guess to this function. Let's define it. Inside the body of this function, we first check if the guess is equal to the num variable. If it is, we show feedback to the player, something like correct. Save and run the game. The number is 64, and as you can see, by entering 64 into the box, the feedback shows that it's correct. We can display the feedback in green to make it visually clear, so let me pass that color in. A better approach for our game logic is to emit signals when the player wins or the game is over. So let's define those signals. At the top of our script, define a new signal named win, which takes an argument called guess. Also define another signal named game over. This one doesn't need any arguments. Now, inside the compareGuess function, when the player guesses the number correctly, we'll emit the win signal and pass the guess into it. We'll handle what happens when the signal is fired later. For now, let's also show feedback when the guess number is less than or greater than the random number. And at the end of the function, we'll call focus on input box to reselect the input field. It's time to think about stopping the game logic. Let's define a new function named stopGame right after the startGame function at the top of our script. This function will take a string message and a color, which we'll set to text color as the default. When the game stops, we want to do a few things. First, set the editable property of the input box to false, so the player can't interact with it anymore. Next, show feedback to the player by calling show feedback and pass in the message and color. Finally, show the play again button and hide the submit button. To handle our custom signals in the script, let's select the main node. Now, if you open the node panel, you'll see the win and game over signals. Let's start by connecting the win signal. Whenever this signal is fired, we'll call the stop game function. For the message, we can use a formatted string like correct. The number was %d, you guessed it, in %d tries, where %d stands for an integer placeholder. After the string, we add a % and then pass an array with num and count guesses to replace those placeholders. I realized that passing the guess argument into the win signal is redundant, so I'll remove it. That means we'll also erase it from the signal definition and from the compare guess function where we emit the signal. Save and run the game. As you can see, it works, but the feedback is showing in the wrong color. Let's fix that by passing the green color constant into the stop game function call. Save and run the game again. Perfect. Now that the game stops when the player guesses correctly, we need a way to reset the game, and that's exactly what the Play Again button is for. So, let's select the button in the node tree, and in the node panel, connect its pressed signal to the script. When this signal is fired, we'll simply call the start game function. Save and run the game. As you can see, we need to tweak that function, because although the submit button shows, the play again button hides, and a new number is generated, the input box is not editable. Let's go back to the start game function. Here, we need to set the input box editable property to true again. Save and run the game. It runs perfectly. Our last piece of logic for this game is handling the guessing tries limit. Quick reminder while we're in the middle of things. If you're finding this helpful, go ahead and smash that like button. And if you haven't already, subscribe to the channel and hit the notification bell. Make sure it's set to all, so you don't miss the next part of this series or any future tutorials. All right, let's keep going. First, select the main node and connect the custom game over signal to the script. Here, I'll copy and paste the same stop game call we used for the win signal, but I'll change the message to something more relevant and set the color to red. Before we use this signal, let's define a new function named update tries. Whenever this function is called, we'll update the tries label to show how many guesses the player has. Let's use this function inside input box submitted. I'll rearrange and tidy up the function body. After validating the text input, we increase count guesses and then call update tries. It's a good practice to write clean, meaningful comments, so I'll fix those too. Save and run the game. As you can see, the tries label updates correctly, except for the first run, where it shows the wrong max count. Let's go back to start game. Here, we can simply call update tries so the UI is correct from the start. Save and run the game again. Perfect. Now that we're showing how many guesses the player makes, we need to limit them. Inside the input box submitted function, at the end of its body, we check if count guesses is greater than or equal to max guesses. If it is, we emit the game over signal. Let's test it. Save and run the game. We can guess 3 times at most. If I try 3 times incorrectly, the game ends correctly. But what if I guess the number on the 3rd try? As you can see, the game over signal still emits, which it shouldn't. Let's fix that. At the top of the script, create a new Boolean variable named isPlayerWin and set its initial value to false. Inside the onWin function, which runs when the win signal is emitted, we set isPlayerWin to true. Also, inside the start game function, reset isPlayerWin back to false. Now, go back to where we emit the game over signal. Update the condition to check if count guesses greater than or equal to max guesses and not isPlayerWin. Save and run the game. It's not working as expected, and that's because I forgot to insert the not keyword before isPlayerWin. So the code was checking against a true value instead of a false one. Let's fix that. Save and run the game again. It works perfectly now. Finally, in the start game function, let's pass an empty string to the show feedback function call, just to clear out any leftover messages. Also, I noticed my game title isn't correct. Let me fix that real quick. Now, here's a neat tweak to make our project more dynamic. Let's export the max guesses variable. This way, we can change it directly from the inspector panel without editing the script. Let me do that. As you can see, by selecting the main node, a new property appears in the inspector with 3 as the default value. Let me change that to 6. Save and run the game. Now we get 6 tries just like that. And that's it. I hope you enjoyed this tutorial and learned something new.